we're going to be discussing some questions that will be helpful to solve assignments for week 3 of this multivariable calculus course. And now, before starting solving some questions, I'm gonna write a question that was asked in GATE 2021, and the concept of directional derivative. I think this is very important to write here. And so in the last class, I gave a new concept of directional derivative. So it says that if f is differentiable, then the direction derivative of f uh, then the direction derivative of f in the direction p at the point a comma p is nothing but gradient of f evaluated at a comma p dot product by p. Okay, so this dpf of a comma p is defined as limit t tends to 0 f of dp1 comma p plus dp2 minus f of a comma b divided by t. And okay, so this is called directional derivative. Here p is p1 comma p2. Okay, so now let us write the question. So let f from R2 to R be differentiable let tu f of 0 0 and gv f of 0 0 be the directional derivative of f at 0 comma 0 in the directions of the unit vectors u equals to 1 divided by square root of 5 comma 2 divided by square root of 5 and v equals to 1 divided by square root of 2 comma minus 1 divided by square root of 2 respectively. If du of f of 0 0 is square root of 5 and dv of f of 0 0 square root of 2, then del f del x at 0 0 plus del f del y at 0 0 is to find this we have to find out from this question. So now we're going to do solution. Okay, so now using the above definition of directional derivative and the connection between directional derivatives and the gradient, you can write du f of 0, 0 is same as gradient of f at 0, 0 inner product u, and dv f of 0, 0 is gradient of f at 0, 0 multiplied by v. So this is a dot product. So since du f of 0, 0 is root 5, so this is gonna be square root of 5 equals to 1 by root 5 fx 0, 0 plus 2 by root 5 fi 0, 0, and similarly square root of 2 equals to 1 by root 2 fx 0, 0 minus 1 by root 2 fi 0, 0. Now this will imply fx 0, 0 plus 2 fi 0, 0 is 5 and fx 0, 0 minus fi 0, 0 is 2. So now we can take sum. So it should be negative, it will be positive, and this will be negative. So we have 3 fi 0, 0 is 3, and this is implying fi 0, 0 is 1. And again, fx 0, 0 will be 2 fi 0, 0, which is equals to 2 plus 1, and that is 3. So del f del x at 0, 0 plus del f del y at 0, 0 is same as fx 0, 0 plus fy 0, 0. So this will be 3 plus 1 equals to 4. So fx 0, 0 plus fy 0, 0 should be 4. And this is our answer. So I hope this is clear. Okay. So now we're going to move on to our next question, which is question number 2. Okay. So it is given that if fxy equals to x to the power 5 plus y to the power 5 divided by x square plus y square, then find the value of fx plus yfi. Okay. So now before solving this question, we're going to recall the definition of homogeneous function. So function f is called homogeneous of degree n if f of lambda x equals to lambda time lambda to the power n times f of x. Okay. So here x can be any vector, suppose x1 dot xm in Rm. So in our given question, f of lambda x comma lambda y, and this will be lambda x to the power 5 plus lambda y to the power 5 divided by lambda x square plus lambda y square. So this will be lambda to the power 5 x to the power 5 plus y to the power 5 divided by lambda square times x square plus y square. So this is gonna be lambda q time f of x comma y. So f is a homogeneous function of order 3. Okay. Okay. So now we're going to write another theorem, which is called the Euler's theorem. Okay. So it says that if fxy is a homogeneous function of degree n in x and y and has continuous first and second order partial derivatives, then x of x plus y of y is n, and x squared fxx plus 2xy fxy plus y squared fyy is, so this will be nf, so n into n minus 1 f. So this is the two theorem. Now since in the question they've asked that what is x of x plus y of y, so that's why we're going to use the first theorem, this one. Now since in the question f is a homogeneous function of degree 3 by Euler's theorem, we have x fx plus y fy equals to nf. Now here our n is 3, so this will be 3f. So x fx plus y fy should be 3f. Hence this is the answer of this question. So I hope this is clear. Okay, so now we're going to move on to the next question. Okay, so the question is given like this. Find out the Jacobian del uv divided by del xy, where u equals to e to the power x sin y, and v equals to x ln of sin y. Then find del xy by del yv. Okay, so now we're going to do the solution. Okay, so we all know that the Jacobian formula is given by del uv divided by del xy equals to determinant of del u del x, del u del y, and del v del x, del v del y. Okay, so let's call this as 1. So now we have to find out all the partial derivatives, and since u is e to the power x sin y, so del u del x will be same as u, which is e to the power x sin y, and del u del y will be e to the power x cos y. Similarly, del v del x will be now since v is e to the power x cos y, sorry, e to the power x ln of sin y. So del v del x will be e to the power x ln of sin y, and del v del y will be x time del y of ln of sin y. So this is gonna be x time 1 by sin y into cos y. So this will be x time cot y. So the Jacobian J is del uv divided by del xy, which is e to the power x sin y, because this was the definition that it will be the determinant of del u del x, del u del y, del v del x, and del v del y. So this is gonna be e to the power x sin y, e to the power x cos y into ln of sin y into x cot y. So yeah, I hope this is clear. No, this was x. So this is gonna be simply ln of sin y. So now this determinant will be e to the power x sin y into x into cos y divided by sin y minus e to the power x cos y into ln of sin y. So this will be x e to the power x cos y minus e to the power x cos y ln of sin y. So it will be e to the power x cos y x minus ln of sin y. So this should be the answer. Hence, this is our Jacobian. Okay. So this is the answer of the first question. Now they have asked another question, that what is del xy divided by del uv, correct? So Del xy divided by del u v is nothing but del x del u, del x del v, and del y del u, del y del v, right? So now since del xy divided by del u v multiply by del u v into del of xy is 1. So from here we can say, so already we know this one, correct? We know this one. We have to find out this one. So we can just replace this by Jacobian. So this will be del xy divided by del u v will be 1 times j. So this is going to be 1 time e to the power x cos y into x minus ln of sin y. So this is going to be e to the power minus x sec y divided by x times ln of sin y. So I hope this is clear, and those of you who joined later can see the video again. I mean, when it will be available on YouTube. Okay. So now I'm going to go to the next question. This is regarding tangent plane and normal line. So this is question number 4. Okay. So the question is given like this. If the equation of the tangent line sorry, tangent plane, not line, to the surface uh, 2x square plus 3y square minus z square equals to 5 at 3 minus 2 and 5 is alpha x plus beta y minus 5z equals to 5. Then find the value of alpha plus beta, and also find the equation of the normal line. At 3 minus 2 and 5. Okay. So we're going to do the solution. And before that, I'll explain again what is the equation of a tangent plane and how it is coming. Now we know the level surface is nothing but defined as if x, y, z equals to c. So now suppose this is a level surface. Okay, now suppose this is the level surface, and this is the equation of a tangent plane. So now let us take a point P here, P0 here, like x0, y0, and z0. And we have to find out the equation of a tangent plane, this one. So this is the tangent plane T. So now for this reason, we just take another point here, such as XYZ. Then we then we join these two lines, this 2 point. So let us call it as P1. And since the gradient is nothing but the normal to the tangent plane, So this will be our gradient of f at p naught. Now from here we can see that this pp1 will be perpendicular to gradient of f at p naught, correct? So that means if you just multiply the direction ratios of pp1 with the gradient of f, and then we can do the dot product, and then we can get the equation of the tangent plane. Now what is gradient of f at p naught? So this is gonna be del f del x at p naught, del f del y at p naught, and del f del z at p naught. Okay, and pp1 is nothing but, I mean the direction ratios of pp1 is nothing but x minus x naught, y minus y naught, and z minus z naught, correct? And this is perpendicular, so the dot product will gonna be 0. So this will be x minus x naught into del f del x at p naught plus y minus y naught into del f del y at p naught plus z minus z naught into del f del z at p naught will be 0. So in other words, x minus x naught at fx of x0 y0 z0 plus y minus y naught into fy of x0 y0 z0 plus z minus z naught into fz of x0 y0 z0, and this is gonna be 0.
Sir, you're
Correct?
muted.
Oh, am I muted? Oh, sorry. Now can you hear me?
Yes, I can hear
Okay,
you.
yeah, thank you so much. I hope the video was recorded. I don't know what happened. Okay, yeah, thank you. So is this clear so far?
Yes, sir.
Okay, so yeah, so now function is given by f of x, y, z equals to c was given, right? Yes, c was 5, and f of x, y, z was 2x square plus 3y square minus of z square. Okay, so and here del f del x will be 4x, del f del y will be 6y, and del f del z will be minus of 2z. Now the point was given like 3 minus 2, 5. Okay, so del f del x at p naught will be 12, del f del y at p naught will be minus of 6, and del f del z at p naught, sorry, it will be, yeah, it will be minus of 10. So the equation of the tangent plane will be 12 times x minus 3 minus 6 times y plus 2 minus 10 times z minus 5 equals to 0. So if you just simplify, it's gonna be 12x minus 6y minus 10z equals to 36 plus 12 minus 50. So this is gonna be 8. So the equation of the tangent plane at p naught is 12x minus 6y minus 10z equals to 8. So this is the equation. So now we have to compare it with alpha x plus beta y minus 5z equals to 8. Okay. So it's gonna be, so this was 12, right? This is gonna be minus of 12, right? Not minus of 6. So this will be 12y and this will be 24. So this is gonna be 10. Okay. Or in other words, 6x minus 3y minus 5z equals to 5. Okay. So now the equation of the tangent plane was given by uh, alpha x plus beta y minus 5z equals to 5. So now if you compare with the previous tangent plane, which is 6x minus 3y minus 5z, then we can see that alpha is 6 and beta is minus 3. So alpha plus beta should be minus 3 plus 6, which is 3. So this should be the answer for the first question. So 6. Are you doing the calculation with me? So this is gonna be 6, right? So this will be 0. Yeah. Are you doing the calculation also? Okay. And the equation of the normal line to f of x, y, z equals to c at x0, y0, z0 is x equals to x0 plus fx at x0, y0, and z0 into t, y equals to y0 plus fy at x0, y0, z0 into t, and z equals to z0 plus f of z at x0, y0, z0 into t, where t is r. Now this equation is coming from the definition of the normal line. So this was our level surface, and this was the tangent plane, and this was the point P0. So now this is the line gradient of f. So now if you take a point here, so let us call it P or P1, which is xyz, then we can see that P0 P1 is lying on the same direction as gradient of f. So P0 of P1 will be nothing but T of gradient of f. Now since we know that P0 of P1 is the direction ratios of P0 of P1 is x minus x0, y minus y0, and z minus z0. Now if you just put all the values here, then you will get x minus x0 equals to t times gradient of del f del x at P0. Similarly, y minus y0 equals to t times del f del y at P0, and z minus z0 equals to t times del f del z into P0. So that's how you get the equation of the normal line. Okay. So now if you just put all the values, since P naught equals to x0, y0, and z0. So this is 3 minus 2 and 5. So our x will be x naught is 3 plus 12 times t. That was our del f del x naught. While gonna be minus 2 times minus 12 of t, and z gonna be 5 times minus 10 of t, because this was our del f del y, which was del f del x was at p naught was 12. Similarly, del f del y at p naught was minus 12, and del f del z at p naught was minus of 10. So this should be the equation of the normal line. Equation of the normal line. Okay. So I hope this is clear and you're following also. And if there is any doubt, you can ask me always in this live class. Otherwise, we're going to go to the next question. So I think this is question number 5. Okay. Let the equation of the normal line to the surface x square plus 2y square plus 3z square equals to 6 at 1, 1, 1 is x equals to 1 plus pt, y equals to 1 minus qt, and z equals to minus of r plus 60. Then find the value of p plus q minus r. Okay. So now we're going to do the solution. So fxyz is given as x square plus 2y square plus 3z square. So del f del x will be 2x, del f del y will be 4y, and del f del z will be 6z. Correct? So if x at 1, 1, 1 is going to be 2, if y at 1, 1, 1 is 4, and if z at 1, 1, 1 is 6. So our equation to the normal line is x equals to 1 plus 2t, y equals to 1 plus 4t, and z equals to 1 plus 60. So where t is in set of real numbers. So now if you just compare with the given normal line here, so let us call it as 1 and let us call it as 2. Then comparing 1 and 2, we have, so here 1 plus pt is 1 plus 2t. So p will be 2. 1 minus qt is 1 plus 4t. So q will be minus of 4, and minus r plus 60 is 1 plus 60. So r will be minus of 1. Hence, p plus q minus r is going to be 2 minus 4 plus 1. So this will be minus of 1. So minus of 1 should be the answer. Okay. Is it clear? Okay. So I hope this is clear. Okay. So we're going to go into the next question if this is clear. So if there is any doubt, you can ask me always. So this will be question number 6. Okay. So find out the critical points of the function fxy equals to y square plus 4xy plus 3x square plus x cube. Okay. So critical points mean we have to put fx to be 0, fi to be 0, and then we have to find out the solution. And those points will be nothing but the critical points. Okay. So we have to put fx and fy both to be 0. So f of x is nothing but tail of tail x, which is 4y plus 6x plus 3x square. And fy is nothing but tail of tail y, which is 2y plus 4x. Yeah, that's all. So if you not put fy to be 0, this will imply 2y plus 4x is 0. And this will imply y equals to minus of 2x. Okay. So now call it as 1, 2, and call this as 1. Now substituting 2 into 1, we obtain. So now since fx equals to 0, so this will imply 4 times minus of 2x plus 6x plus 3x square equals to 0. So this will imply minus 8x plus 6x plus 3x square equals to 0. And this will imply that 3x square minus 2x is 0. So the solutions are x into 3x minus 2. So either x is 0 or 3x minus 2 is 0, and this will imply x is 2 by 3. Okay. Now from 1, we have, now for x we have got two solutions. One is 0 and another is 2 by 3. So we have to substitute these two value in 2, not 1. So this will be 2. and y was minus of 2x. So when x is 0, y will be minus 2 times 0, that is 0. And when x is 2 by 3, y will be minus 2 times 2 by 3, which is minus 4 by 3. Okay, so the critical points are the critical points of f are 0, 0 and 2 by 3 comma minus 4 by 3. So these are the critical points. Okay, and now we can also try to find out what are the minimas or what are the maximas of this function. So the question only asks for the critical points, right? So the answer should be 0, 0 and 2 by 3 comma minus 4 by 3. So this should be the answer. Okay, but in case we want to know uh, what is the maxima or what is the minima or what are the minimizer or the maximizer for this function, we can do this. Now, before that, we have to know what is the second order derivative test. So first, I'm going to write the formula to like how to find out which point is a maxima or which point is a point of minima or which point is a saddle point, and then we'll solve this question. So this is called second order derivative test. Okay, so it says that if we have a critical point a comma b, okay, then we have to calculate this Hessian, which is till square f by till x square into del square f by del x del y into del square f by del y del x into del square f by del y square. So this is nothing but fxx into fyy minus fxy square. Now if we assume that the partial derivatives are continuous and the second order mixed partial derivatives are all existing or they all exist, then we can say that they are all equal. That is fxy is same as fyx. So from here it says that if, so let us call it as h. So if h is greater than 0, not only h greater than 0, we have to evaluate at the point a comma b. So if h at a comma b is greater than 0 and if xx at a comma b is greater than 0, then a comma b is a point of local minima. Okay, or simply point of minima. And if h sorry h at ab is greater than 0 and if xx ab is less than 0, then a comma b is a point of local maximum. Okay, and if h of AB is less than 0, then A comma B is a saddle point. And if h evaluated at A comma B is 0, then the test is inconclusive. Okay, so this is called the second order derivative test to find out a critical point is a maxima, minima, or a saddle point. So now I think we can solve some questions, or maybe you can solve this question at the point 0, comma 0. So our fx was given by 4y plus 6x plus 3x square. So fxx will be 6 plus 6x. Similarly, fy was given by 2y plus 4x. So fyy will be 2. Similarly, fxy will be 4 and fyx will be also 4. So now the Hessian at evaluated at a comma b will be fxx into a comma b multiplied by fy into a comma b minus fxy evaluated at a comma b whole square. So this is gonna be, so the point, so let us just take the point a comma b as 0 comma 0. So this will be 6 times, since fyab is 2y plus 4x, sorry, this will be fyy. So this will be 2 minus fxy will be 4. So this is 12 minus 16. So this is going to be minus of 4, which is less than 0. So this is implying that 0 comma 0 is a saddle point. Okay. So our next point was 2 by 3 comma minus 4 by 3. Okay. So at this point, h of 2 by 3 comma minus 4 by 3. So this is going to be fxx is 6 plus 6x. So this will be 6 plus 6, just 12 times 3 multiplied by 2 minus, because fyy is 2 and fxy is 4. So this is going to be 4. So this is 30 divided by 3 into 2 minus 4. Okay. So this will be 60 divided by 3 minus 4, which is 60 minus 12 divided by 3. So there should be, or something like simply 20 minus 4, which is 60 greater than 0. Again, fxx at 2 by 3 minus 4 by 3 is nothing but 6 plus 6x. So this will be 6 plus 6 times 2 by 3. So this will be 6 plus 12 by 3. So this will be 10. This is also greater than 0. So thus we have 2 by 3 comma minus 4 by 3 as a point of local minima. So I hope this is clear. Is there any doubt? Is there any doubt? Okay,
No, sir.
okay, yeah. So I think then I'm gonna move on to the next question if there is no doubt. So I'll be solving some interesting questions, and I think this will be helpful, of course, for the assignment, and also it will be helpful for any type of like competitive exam where this type of questions are asked. For example, the GATE exam or the IT Jam exam. For this type of exam, I think it will be very helpful. So yeah. So now we're gonna go to the next question. So this will be question number, sorry. So yeah, 7. So this will be question number 7. Okay. Examine the local extrema of the function f of xy equals to 6xy minus x square minus of y cube. Okay. So yeah, we're gonna go to the similar procedure. That's what we have done just earlier. So first will be uh, s- uh, uh, we'll be computing the partial derivative with respect to x. So this will be 6 times y minus 2 times x. Similarly, fy of xy will be 6x minus 3y square. So now we'll put fx 0, and this will give us 6y minus 2x equals to 0, and this will be x equals to 3y. Now if we again put fy to be 0, then fy will be 6x minus 3y square is 0. Now x is 3y, so 6x will be 18y minus 3y square equals to 0. So this will imply that y times 6 minus y equals to 0. Okay, so this will imply that y is either 0 or 6. So now if you put the values here, then y equals to 0 will imply x equals to 0, and y equals to 6 will imply x equals to 18. So the critical points are 0, 0, and sorry, this will be 18,6. Okay, so now to check if what are the points of local minima or maxima. So local extrema means either local minima or local maxima. So that's why it's called the extremum points. Okay, so it's combined, it's called extrema. So now if xx at xy, so our fx was 6y minus 2x, so fxx will be minus of 2, and fyy of xy, this is gonna be this, it was 6x minus 3y square, so it will be minus of 6y, and if xy of xy, it will be 6. Okay, okay, so now at 0 comma 0, if xx at 0 comma 0 is minus of 2, if yy at 0, 0 is 0 and if xy at 0, 0 is 6. So Hessian evaluated at 0, 0 will be fxx 0, 0 into fyy 0, 0 minus fxy 0, 0 square. So this is gonna be 0 times minus of 2 minus of 6 square. So this will be minus of 36. Okay. So this is implying that 0, 0 is a saddle point of f. Okay. Now what about the next point at 18, 6? So at this point, fxx 18 of 6 will be minus of 2 because fxx at x, y was minus of 2 for any x and y. And if yy of 18, 6 will be minus of 6 times 6, which is minus of 36. And fxy of xy will be 6 because it was like fx of xy was 6 for every x and y. So not xy at 18, 6, it will be still 6. Okay. So the Hessian evaluated at 18, 6, this is gonna be minus of 2 times minus of 36 minus of 6 square. So this is 72 minus 36, which is 36 greater than 0. Now since the Hessian is strictly greater than 0, we have to check the values of fxx at the point 18, 6. Now if xx 18, 6 is minus 2, which is less than 0. So this implies that 18, 6 is a point of local. So is it minima or maxima? Any guess? So it will be a point of local maxima or local minima. So since the Hessian is greater than 0, if if of xx is strictly less than 0, then the point will be point of local maxima. If it is strictly greater than 0, then it will be point of local minima. Now since it is strictly less than 0, so 18, 6 will be a point of local maxima. Okay. So I hope this is clear. Okay. So now I'm gonna do a question which was asked in GATE. I'm not sure about the year, but I think it was GATE 2020 probably. Okay. So this will be question number 8. So is there any doubt in the previous question? Is it clear? So I think it was straightforward, right? Okay. So we're gonna go to the next question. Let f from R2 to R be given by fxy equals to 4xy minus 2x square minus y to the power 4. Then f has a point of local maximum and a saddle point. Okay. A point of local minimum and a saddle point. Next option is a point of local minima and a point of local maxima. And next option is two saddle points. Okay. So the question is given like this. A function f from R2 to R is given by fxy equals to 4xy minus 2x square minus y to the 4. Then they are asking about points which are like point of local minima or local maxima and or saddle points. So for that reason, we have to go through the same procedure what we have did just earlier. So first we're gonna find out the partial derivatives with respect to x. So this one will be 4y minus of 4x, right? And the partial derivative with respect to y will be 4x minus of 4y cube. So now, so yeah, I think these are correct because fxy was 4xy minus 2x square minus y to the power 4. So fx will be 4y minus 4x and fy will be 4x minus 4y cube. So now if we just put fx equals to 0, so this will be 4y minus 4x is 0. This will imply y equals to x. And similarly, if you put fy equals to 0, you will get 4x minus 4y cube equals to 0. So this will imply x minus y cube is 0. And this will imply x minus x cube is 0 as y equals to x. Okay, from here. So let us call it as 1 from 1. Okay, now this is implying that x time 1 minus x square is 0. So this is implying x is 0, 1 and minus 1. Okay, so the points are, or the critical points are 0, 0, 1, 1 and minus 1, minus 1. Because y equals to x, so all the points will be same. I mean the x coordinate and y coordinates for each points will be same. Okay, so now we have to find out fxx. So if xx is minus of 4 and fyy from here, it will be minus of 12 times y square, and if xy, this is gonna be 4. Okay, So now here if x at 0 0 is minus of 4, if y at 0 comma 0 is 0, and if xy at 0 comma 0 is 4. So we now evaluate the Hessian at 0 comma 0, which is fx at 0 0 minus fyy is 0 0 minus fxy 0 0 square. So fx 0 0 is fx 0 0 is minus of 4 times 0, because fyy 0 0 is fyy 0 0 is 0, and this will be minus of 4 times square. So this will be minus of 16 less than 0. Correct? So this is imply that 0 comma 0 is a, any guess what point this will be at 0 comma 0? So the Hessian has come to be negative. So what should be the answer here? A saddle point, right? Okay. So now we have to find out at the point 1 comma 1 and minus 1 comma minus 1. So at 1 comma 1, if xx at 1 1, so this is gonna be, so since if xx of xy was minus of 4, so this will be still minus of 4. If yy of 1 1 will be minus of 12 times 1, so which is minus of 12. And if xy at 1 1, this will be 4 again. So h of 1 comma 1, so this is gonna be minus of 4 times minus of 12 minus of 4 square. So this will be 48 times 48 minus of 16. So this should be 32, which is greater than 0. Now we have to check if xx at 1 comma 1, which is minus 4 and less than 0. So that imply that 1 comma 1 is a point of local maxima. Okay, is it clear? Because the Hessian is positive, so we have to check the uh, value of fxx at the point 1 comma 1. Now since it has come to be negative, so it will be a point of local maxima, and if it was like positive, then it will be a point of local minima. I think this is clear now. So now we have to check to the next point, which is at minus 1 comma minus 1. So at this point, fxx at minus 1 comma minus 1 will be still minus of 4, but fxy of minus 1 comma minus 1 will be minus of 12 times minus of 1. Okay, so this is gonna be 12. So sorry, no, this was y square, so it will be still 12 minus of 12, sorry. And if y of minus 1 comma minus 1, and it will be, sorry, this is fxy, so this is gonna be fyy, and this is gonna be fxy. So it will be 4. Okay. So now the Hessian evaluated at -1, -1, it will be fxx evaluated at -1, -1 into fyy at -1, -1 minus fxy at -1, -1 square. Okay. So this is gonna be again minus 4 times minus of 12 minus of 4 square. So this will be again 48 minus 16, which is 32 greater than 0. And fxx at -1, -1, this is will be minus of 4, which is less than 0. So this implies that -1, -1 is also a point of local maxima. Okay. So we have got 3 points, 0, 0, 1, 1 and -1, 1. So the status is this is the saddle point, and this is the maxima. So this is point of maxima, and again this is also point of maxima. Hence we get one saddle point and at least two, or maybe exactly two point of maximum. So according to the options, first one was a point of local maximum and a saddle point. So yeah, this is true because we already have got two local maximum. I mean 2 point of local maxima. So this is a correct option. So a point of local minimum, no, this is not correct. Third point is a local point of local minima and a point of local maxima. No, this is not true because we have not got any point of local minima and two saddle points. This is also not true because only one point is a saddle point, which is 0, 0. So only the first option should be correct. Okay. Is it clear or is there any doubt? Is it clear? Okay. So I think then I'll move to the next question. So this will be question number 9. Okay. So it is given that let u of xy equals to x squared plus y squared times sine inverse of x squared plus y squared divided by 2xy. Then find the value of x squared uxx plus 2xy uxy plus y square uyy. Okay. So yeah, now we're gonna do the solution. Okay. So I think we'll be using the Euler's theorem, and as we have seen in case of Euler's theorem. So Euler's theorem says that if so I'm going to write the theorem here. If f is a homogeneous function of degree n, then so then it says that x squared if xx plus 2xy if xy plus y squared if yy. This is n into n minus 1 times f. So basically, we have to find out the degree of this homogeneous function. So to check that, we have to find out u of lambda x comma lambda y. So this will be lambda x square plus lambda square multiplied by sine inverse of lambda x square plus lambda y square divided by 2 lambda square xy. Okay, so this will be lambda square times x square plus y square into sine inverse, and this will be lambda square times x square plus y square by 2 lambda square xy. So this is going to be lambda square time. So this will get cancelled out, and this will be fxy. So f is a homogeneous function of degree 2. Okay. Now by Euler's theorem, we have we'll get x square uxx plus 2xy uxy plus y square uyy. This will be 3 times, sorry, this will be 2, but degree is 2. So 2 times 2 minus 1 into u. So this will be 2u. So this should be the answer. So x square uxx plus 2xy uxy plus u square uyy, sorry, y square uyy. This is gonna be 2u. So this should be the answer. Okay. Okay. So now I'll be writing another question. Now suppose u is given like this. Sine inverse of x square plus y square divided by 2x. Okay. So now in this case, it will be u of lambda x comma lambda y equals to sine inverse of lambda square time x square plus y square divided by 2 lambda x. Okay. So this will be sine inverse time uh, okay. So let me just correct it. U of xy equals to x cube plus y cube plus sine inverse of x square plus y square by 2xy. Okay. So then u of lambda x comma lambda y will be lambda x cube plus lambda y whole cube into sine inverse time lambda square into x square plus y square divided by 2 lambda square into xy. Okay, so this is gonna be lambda q times x cube plus y cube sine inverse of x square plus y square by 2xy. So this is nothing but lambda q times u of xy. Hence, u is a homogeneous function of degree 3. Okay, hence by Euler's theorem. So by Euler's theorem we have x square u xx plus 2xy uxy plus y square uyy 3 into 3 minus 1 u. So this will be 6u. Okay, so this should be the answer. So I hope this is clear now. So we have solved 2 questions in this type of cases, like using Euler's theorem for second order partial derivatives. Okay, now we'll go to the next question. So this will be question number 10. So this will be question number 10. Okay, so examine the relative extrema of the function f of xy equals to 4x square plus y square minus of 2x plus 1. Okay, also find the relative extrema value. Okay, so now, so the routine calculation we have to do. So now again we'll find fx at x comma y, which will be 8x minus 2. Fy at xy will be 2y, and also we'll find out if xx xy, this will be 8. Fyy xy, this will be 2, and if xy xy, this is gonna be 0. Now to find the critical points, let us just put fx xy to be 0, and this will give x to be 1 by 4, and fy xy equals to 0 will imply y equals to 0. So 1 by 4 comma 0 is a critical point of f. Okay, Now if xx at 1 by 4 comma 0, this is gonna be 8. If yy at 1 by 4 comma is already 0, f of 1 by if yy of 1 by 4 comma 0 is 0, and sorry, this will be 2, and if xy of 1 by 4 comma 0 will be 0. So if xx at 1 by 4 comma 0, so this is our Hessian at 0 comma 1 by 4 comma 0. So h of 1 by 4 comma 0, this is gonna be if xx at 1 by 4 comma 0 into if yy at 1 by 4 comma 0 minus if xy at 1 by 4 comma 0. So this is gonna be 8 times 2 minus 0. So 16, which is greater than 0. And again, if xx at 1 by 4 comma 0, this is 8, which is greater than 0. So 1 by 4 comma 0 is a point of local minima. Okay, so yeah, I think this should be the answer, and the corresponding value will be, or the corresponding minimum value will be f of 1 by 4 comma 0. So our fxy was 4x square plus y square minus 2x plus 1. So this will be 4 times 1 by 4 4 times 1 by 4 square plus 0 square minus of 2 times 1 by 4 plus 1. So this is going to be 1 by 4 minus of 1 by 2 plus 1. So this will be 1 by 4 plus 1 by 2, and this is going to be 3 by 4. So this is our the minimum value. Okay. So now we're going to go to the next question, which will be question number 11. Okay. So let fxy equals to x square plus xy square plus y to the power 4. Then show that 0 comma 0 is a global minima of f. Okay. Now this is a very good question. So I'm gonna give it as 3-star question. Okay. This is very important question. Now in the first attempt, we can try to solve it using second derivative test or the second order derivative test, and then you can see that this test will fail at the point 0 comma 0, because our fxy is x square plus xy square plus y to the power 4. So fx will be 2x plus y square. Similarly, fy will be 2xy plus 3y cube. Now if we just put fx to be 0, so this will imply x is minus of y square by 2. Okay, and fy is 0, this will imply 2xy, this will be 4y cube plus 4y cube equals to 0. So since 2y into minus y square by 2 plus 4y cube is 0. So this is implying minus y cube plus 4y cube is 0. So this will imply 3y cube is 0 and hence y is 0. And y is 0 will imply x equals to minus of 0 square by 2 is 0. Correct? So 0 comma 0 is a critical point of f. Correct. So now if you try to calculate the Hessian at 0 comma 0, then we can see that the Hessian will come to be 0. So see that if xx will be 2, correct. If yy will be 2x plus 12y square. And if xy will be 2y. Okay. So if x at 0 0 will be 2, if yy at 0 0 will be 0, and if xy at 0 0 will be also 0. Hence the Hessian evaluated at 0 comma 0 is going to be fxx 0 0 into fyy 0 0 minus of xyy fxy 0 0 square. So fxx 0 0 is 2 times 0 minus 0 square equals to 0. So now by the second order derivative test, we can say that the test is inconclusive. So that means we cannot conclude anything from here. So then how to do this? I mean, how to solve this question? How to find out that 0 comma 0 is a point of global minimum? Now for that reason, we have to go through by the definition of point of global minimum. Now what is the definition? So the definition says that the function f from R2 to R has a, so just let f from R2 to R has a critical point a comma b, and if fxy is greater equals to fab for all x comma y in R2, then a comma b is a point of global minimum. Okay, so here you don't need necessarily that a comma b to be critical point. If fxy is greater equals to f of ab for every x and y in R2, then we can guarantee say that the point a comma b is a point of global minima. Okay. Now here, if we can somehow show that f of x comma y is greater equals to f of 0 comma 0 for every x and y, then we can surely say that 0 comma 0 is a point of global minimum. Okay. So now look at our function. So if xy was x square plus xy square plus y to the power 4. So this can be written as x square plus 2 times x times half y square. This will be minus half times y to the power 4 plus half times y to the power 4 plus y to the power 4. So this can be written as x square minus of, sorry, this will be plus minus plus, so x square plus half y square whole square. This is gonna be 1 by 4. So this will be 1 minus 1 by 4 y to the power 4. So this will be x square plus 1 by 2 y square whole square plus 3 by 4 y to the power 4. So now you see that all the powers of this x square plus half y square and y is positive power. I mean even powers like 2 and 4. So that means fxy will be greater equals to 0 for every x and y in R2. And 0 is nothing but our f of 0 comma 0. This will imply that 0 comma 0 is a point of global minima. Okay, so I hope this is clear, and if it's not clear, then please go through the video again. And again, if you have any doubt, then let me know in the next class. Okay, so now we're going to go to the next question. So this will be question number 12. Okay, if u equals to x cube plus y cube, u equals to xy plus yz, and w equals to z minus x minus y, then find the value of tail of uvw divided by tail of xyz and tail of xyz divided by tail of uvw. Okay, so solution. So tail of uvw divided by tail of xyz, this is gonna be del u del x, del u del y, and del u del z. Similarly, del v del x, del v del y, del v del z, and del w del x, del w del y, and del w del z. Okay, so our del u del x is 3x square, del u del y is 3y square, and del u del z is 0, because here u is not a function of z, correct? Similarly, del v del x is y, del v del y is x plus z, and del v del z is y, and del w del x will be -1, del w del y will be also -1, and del w del z will be 1. Okay, So now we're going to compute the Hessian, the Jacobian. So J equals to del of UVW divided by del of XYZ. So this is 3x squared, 3y squared 0, yx plus z y, and minus 1, 1. Okay. So now we have to calculate this determinant. So this is going to be 3x squared times x plus z plus y minus 3y squared times y plus y. Okay. So this will be 3x cubed plus 3x squared z plus 3x squared y minus 3y cubed. So this will be 2. So this will be 6y cubed. Okay. And our j prime, which is nothing but tail of xyz divided by tail of uvw. This will be 1 divided by z. So this is going to be 1 divided by 3x cubed minus 6y cubed plus 3x squared z plus 3x squared y. So this should be the answer. Okay. So yeah, now we're going to go into the next question, which is question number 13. And hopefully this will be the last question. Okay. So the question is given like this. Find out the absolute extrema value of f where fxy is x square plus xy plus y square minus 6x plus 2 on the rectangle zero less equals to x less equals to 5 and minus 3 less equals to y less equals to 0. Okay, so now let us try to draw the rectangle. So this is the xy plane. Now this is 5 comma 0 and this will be 0 comma minus 3. So this should be the rectangle and this will be 5 comma minus 3 and this will be 0 comma 0. Now let us call this line as L1, this line as L2, this line as L3 and this line as L4. Okay, this is our x-axis and this is our y-axis. Okay, so first we have to do the partial derivatives with respect to x, which is fx and this is gonna be 2x plus y minus 6. Similarly, the partial derivative with respect to y is gonna be x plus 2y. Okay. So now if we just put fx to be 0, this will imply 2x plus y minus 6 is 0, and this is implying y equals to 6 minus 2x. Now let us call this as 1. Then fy equals to 0 will imply x plus 2y equals to 0. Then from 1 we have x plus 2 times 6 minus 2x equals to 0, and this will imply x plus 12 minus 4x equals to 0, and this is implying 12 minus 3x equals to 0, imply x equals to 4. So 4 comma 0 is a critical point of f. Okay, now try to see that the point 4 comma 0 lies somewhere here, which is on the boundary of this rectangle, or on the line L of 3 or L3. So this is going to be the line. Sorry, not 4 comma 0. So x equals to 4 will imply y equals to 6 minus 8. So this is minus of 2. Okay. And this will imply that 4 comma minus 2 is a critical point of f. So now try to see that this point 4 comma minus 2 belongs somewhere here. Somewhere here, yeah. Okay. So which is an interior point of the rectangle. So now in this point, we have to calculate that if this is a point of local maxima or point of local minima. So if xx at 4 comma minus 2, so this will be 2, right? Because fxx will be 2. Similarly, fyy at 4 comma minus 2, this will be also 2. And fxy at 4 comma minus 2, this will be 1. So the Hessian at 4 comma minus 2, this is gonna be 4 times, 2 times 2 minus 1 square, which is 3, and this is greater than 0. Also, if xx at 4 comma minus 2 is 2 greater than 0, right? So thus 4 comma minus 2 is a point of local minima, correct? Not only that, we can prove also that this point is a point of global minima because the function is strictly convex. So this you can see as an exercise, because our function, which is fxy equals to x square plus xy plus y square minus 6x plus 2. Now the Hessian at the point, or maybe the Hessian is 2x, sorry, 2, 2. So fxy is 0. Sorry, fxy is 1. So 2, 1, 1, 2. Now the eigenvalues of HR. So the eigenvalues will be this is x square minus 4x plus 3 equals to 0. So we have to solve this equation. We'll get x minus 3 into x minus 1. So this will be 0, and this will imply x equals to 1 comma 3. So the eigenvalues of h are 1 comma 3. Okay, so that imply that h is a positive definite matrix. So since h is a positive definite matrix, f will be strictly convex function. And since f is a strictly convex function, it will have a at most one global minimum. And since we have found out the 4 comma minus 2 is a point of global minimum and a point of local minimum, and that will be the only point of global minimum in this case. So that's why this is not just a point of local minimum, it's a point of global minimum also. Okay. Okay, so now we have to find out the the critical points or the other critical points. I mean the value of the function, or maybe we have to check the maxima or minima at the boundary of the rectangle. Now for that reason, first we're going to check on the boundary of L1. So at the boundary L1, y equals to minus of 3. So here g1 of x will be f of x comma minus 3. Okay, so this will be x square plus xy, so it will be minus of 3x plus 9 minus of 6x plus 2. Okay, so this will be x square minus 9x plus 11 again. So now since we are evaluating the function on the line of y equals to minus 3, so we can just substitute the value y of minus 3. Then the function is reduced from 2 variable to 1 variable. Now we can use the first variable test, I mean the derivative test of one variable, which we have seen in a real analysis, and then we can try to find out what are the critical points and what are the points of local minima or maxima of G1. So G1 prime of x equals to 0 will imply that 2x minus 9 is 0, and this will imply x is 9 by 2. So, and again G1 double prime of x is 2, which is greater than 0. So this will imply this implies that x equals to 9 by 2 is a point of local, so this is greater than 0, so it will be point of local minima for G1. Okay, and 9 by 2 comma minus 3 is a critical point of F. Okay, so check the behavior uh, check the behavior or check the points on the boundary. Of the rectangle. Okay. Now, for that reason, first we'll consider the straight line L1. I mean the straight line L3. So in the case of the straight line L3, we have y equals to 0, correct? So for this straight line, y is 0. So now if you just put y equals to 0 in the function, that is f of x0, so this is going to be a function of g. So this will be x square plus the y will be 0. So this will be x square minus 6x plus 2. Okay. So now if you just do the derivative, this will be 2x minus 6, and putting g prime of x equals to 0 will imply x equals to 3. Now since the function has been reduced to a one variable case, then we can use the derivative test for one variable, which we have learned in integral analysis. So so here the critical point of g is nothing but x equals to 3. So again, g prime double prime of x is 2, which is greater than 0. So this is implying that 3 is a point of uh, local minima. So now we can say that 3 comma 0 is a critical point. Critical point of f. Okay. Okay. So now let us consider the next boundary case. So we have taken already the L3 line. Now we're gonna take the L2 line. So on L2 line, the x of the value of x is 5. So f of 5 comma y. So let us call it as h of y. So this is gonna be 5 square plus 5y plus y square minus 30 plus 2. So this will be y square plus 5y minus 30 plus 27. So this will be y square plus 5y minus of 3. Okay. So now if you just do the derivative, h prime of y, so this will be 2y plus 5, and h prime of y equals to 0 will imply y is minus 5 of 2. So hence 5 comma minus 5 by 2 is a critical point of f. Okay. Okay. So this was the L2 line. So now we have to take another line. So we're done with L3, L2, and then we will take the line L1. So along L1, we can see that y is fixed as minus of 3. So yeah. So along the line L1, y is minus of 3. Okay. So this will be f of x comma minus of 3, and let us call it as g1 of x, and this is gonna be, so the function value was so this will be x square minus 3 times x plus 9 minus 6x plus 2. So this will be x square minus 9x plus 11. Okay. Then g1 prime of x will be 2x minus 9, and g1 prime of x equals to 0 will imply x equals to 9 by 2. So 9 by 2 comma minus 3 is a critical point of f. Okay, so we are done with L1, L2 and L3 line. So next line will be L4 line. So along the line L4 we can see that x is 0, correct? So this is gonna be the L4 line. So here x is 0. So f of this will be 0 comma y. So let us call it as h1 of y. So this is gonna be y squared plus 2. So h1 prime of y will be 2y, and this will imply and equals to 0 will imply y equals to 0. So 0 comma 0 is a critical point of f. Okay, so that means we have got a bunch of points where we have to check the values of the function, and then we can decide the which point is a point of maximum. So these are the points, and this is the functional value. So the first point was 3 comma 0. So at this point the function value is minus of 7. Next point is 5 comma minus 5 by 2. So here the function value is minus 37 by 4. The next point is 9 by 2 comma minus 3. So here is also minus 37 by 4. At 0 comma 0 it is 2. At 5 comma 0 it is minus of 3. At 0 comma minus 3 it is 11. So at 5 comma minus 3 it is minus of 9, and at 4 comma minus 2 it is minus of 10. So from here we can clearly see the maximum value is 11. Okay, and the point of maximum is 0 comma minus 3, and the corresponding value is 11. So this should be the answer. Now I hope this is clear, and if there is any doubt, and you can always ask me in the next class. So yeah, thank you.